Alright, so this will be an easy one. Or rather a fast one. We're using normal curve to approximate the binomial distribution. So this is more before we had kind of advanced technology to do it for us. But really, we're going to learn about how to use a normal curve to approximate binomial probability. This is more for back when we didn't have this technology to kind of do bigger numbers for us. But really, it's when the binomial distribution is too large, it's much easier to turn it into a normal distribution. So, in order to do this, we need to employ the two formulas we talked about in the last lesson, and that is the mean is n times p, and the standard deviation is the square root of n times p times 1 minus p. Okay, so how does this work? So in a game of baseball, the average players can have about 300 at-bats. So automatically, you're looking at that number 300, and it's too big. See, a sample of 300 is too large. You wouldn't want to do factorials with it. So you would want to use the normal curve. So that number 300, if you did this straight out with a binomial curve, you'd have something like 300, and the one there says 110. So you'd end up having to do like 300 factorial, 110 factorial, and then 190 factorial, and that would just take forever. So instead of doing that, what we want to do is we want to equate it to a normal curve. So in order to do that, we're going to first start off with our mean, which is n times p. And our n is 300, because there's 300 at-bats, and it's a 0.33 for 33% hitting average. And then we do a quick multiplication. That gives us 99. So that means 99 is our average, and then for our standard deviation, n times p times 1 minus p. So that would be the square root of 300 times 0.33 times 1 minus 0.33. Okay. So once I do the math, that gives me 8.1443. So that's going to be my normal curve. 99, 8.1443. Okay, so what is the probability that he hits 110 or more, or 110 balls or less? So what we're going to do is we can do this by hand, or we can do this by stack crunch, which I know is something that most of my students like to do. So let's see. Let me open up my stat crunch here. Right there. Where is my stat crunch? Where's my well, hang on 1 second. Oh, why aren't you opening? Let's try this. That'll work. There we go. So, in StatCrunch, we will go to calculators, normal. Okay, and so now we have our mean of 99. Oops, not double O, 99. Okay, and then we have a standard deviation of 8.1443. And we want less than 110. So we compute, and we're going to end up with let's see, 0.9115, or 91.16%. Okay, so I got that right there. Now let's say if we want to do more than 105, so we'll go back to here, switch this to more, and change this to 105. And so 0.2306 or 23.06%. Switch that back over, and so there's my two percentages. Okay, so once again, another example. I told you this one would be pretty short. It's pretty straightforward and pretty fast. So we want to again, we have 365 days as our n. Which the question says a certain person has 7% chance of getting sick on any given day. In 1 year, 365 days, determine the following probabilities. Again, 365 is too big, so I want to do 365 times 0.07. And that gives me 25.55. And then I want to do the square root of 365 times 0.07. 1 minus 0.07. So let's see. So that gives me 4.8746. Okay, and then for 20, so we'll go back to StatCrunch. So we'll go ahead and our mean we'll put in 25.55. Our standard deviation is 4.8746. And then I want less than 20. So that gives me 0.1274. And while I'm at it, I'm just going to go ahead and get all of these done real fast. The next question says, well, a person gets sick more than 28 days. So I'll switch this over and get 28 days. 0.3076 or 30.76%. And then we're going to go in between. So we're going to be between 23 and 29, and that's going to be 0.4600 or 46%. Okay, and then I'll go back and flip this so you can see all the writing, and that's pretty much it. Pretty simple.